Hello YouTube, this is Alexander again. Today I wanted to talk about this device, which you probably know because if you are a subscriber to my channel, you can see a video talking about this kind of stuff and how you can build it if you need one like this. This device was used in case I need a protection from the main for working on troubleshooting and try to repair some stuff which needs to be connected to the main. Actually, sometimes I connected a power tool which was very greedy actually, and they kill the transformer on it. So this device is dead since few months now, and it was very difficult actually to work without, because when you are troubleshooting computer power supply, for the example, sometimes if you make a mistake on your board, you have the full power coming from the main and it explodes your power supply. So you absolutely need a device like this, but not exactly this one, because this is just what it remains about my lists, because I read some parts, and when I tried to repair something, I dismounted the transformer on it, and I figured out that it was completely burned. The primary winding was completely short circuits. Fortunately, there was a bulb on serial which was always glowing, which indicates to me that this device was short circuit actually. So it was very hard to work without this stuff, because it gives you safety for working and also a limited current to protect your device. So the last time I tried to repair a power supply coming from a computer, I connected the power supply directly to the main, and what happens actually, the power supply, because I did a mistake, I absolutely don't know what about, it explodes in my face like a bomb actually. So it was very scary actually, and I didn't have my safety glasses on me. Sometimes you have some component on a power supply, they explode. They can give you some injuries actually. Sometimes it happens a lot. So you absolutely need this kind of stuff to protect your device and to protect yourself also, because the isolated transformer, which is inside, normally inside, this is not the case because this box is empty now, is able to give you the main without a phase. So this one is not able to work anymore. This is a rubbish actually. But to talk about isolated transformer is something like that. This is a transformer coming from a factory. So this one is given for 100 watts, and sometimes it can be enough for some project and for stuff, and it can be very useful to have it. To talk about this Palmieri Robin, which is a French brand actually, you can see here some information written on the front of this transformer, which is here the power, and here the frequency written here on this label. Here you can see the primary, which is here talking about the voltage in entry. You have here two voltage, 230 or 400 volts in entry, and for the secondary you have 2 times 113 volts with something like 0.8 amp. So this voltage is able to you can use this voltage in serial to have 230 volts, or you can use it in parallel. In this case, it's connected in serial to have a voltage corresponding to the main. So this isolated transformer have particularities. It's you can feed it with 230 or 400 volts. The reason of this different voltage on entry, it's because this is an industrial transformer, and you sometimes you will find this kind of transformer on electrical cabinets or in some factories, because factories works a lot with three-phase voltage, and sometimes you can find some transformer like this to create an equal voltage like the main from 400 voltage, which is actually sometimes the three-phase voltage. But also, if you want to use it like just an isolated transformer, you can also use this primary just this side here between 0 and 230 volts to give a 1-by-1 transformer, which is actually just a galvanic protection. This kind of transformer provide separate circuits, because you have not interaction between the upstream and downstream of this transformer. You don't have electric communication between this winding and this winding, except the parasites, the capacitance parasites, because there is sometimes parasite capacitance on wiring actually. So if we want to see some schematic here, here for this transformer, actually, you can see this schematic here, which is actually a wiring for the main for 230 volts and the wiring for one single phase coming from the main transformer on the factory. So it's used to give a 230 volts here, which is completely separated from this part here. So here you can see a grounded wire here, but there is no grounded wire here, which is the isolated electrical requirement for your ears. So what you can see here, the difference between the direct connection to the main, you will have always a phase, and the purpose here with this kind of device is to disconnect the L1 from the L1 coming from the main, so you will not have a phase corresponding to the earth actually. If you touch this L1 by your finger, you can feel an electric current through your body, which can be very dangerous, and it can kill you also. So what you need here is to erase this danger here. You can use an isolated transformer like here to have L1 and L2 prim, but completely disconnected electrically from the main. Of course, in this case, you have always a dangerous voltage, which is required for your purpose actually. But if you touch one single wire here, but with your hand, you will feel absolutely nothing. Actually, a simple isolated transformer is this part in black. But this one, which is an industrial one, is an isolated transformer with a second wiring, which is the wiring required for the 400 volts, which provides to you to have 230 volts from three-phase voltage. Of course, in this case, one single phase is used, absolutely. So the nice thing to notice here is if you can use a transformer for the isolated properties, you can also use an isolated transformer like this, and you can limit the current, because those transformers are sometimes able to give 100 watts or over there is no limits. Actually, you can find some transformer able to give 1000 watt about coming from a transformer like this. Of course, it's will be more heavy, more big than this one, more expensive, and for our purpose, it's not so useful to have so much power actually, except if you have a very special purpose. So to have a current limiter with this kind of a transformer, and of course to protect your board, your power supply, anything you are working on, you can add some bulb on the entry here with each bulb here is selectable with a switch, as you can see here, and this drawer here is a bulb actually. This one needs to be a low power bulb. This one needs to be a middle power bulb, and this one is a big power bulb. For the instance, this one is usually a 50 watts bulb, this one 150 watts bulb, and this one is 400 or 500 watts bulb. According to the switch you are switching here, you will have here always the same voltage. This is the case for high efficiency transformer. For example, if you take a toroidal transformer, you will have a high efficiency transformer, and sometimes you will have an idle current, very low current when the output is not used. So you can place this bulb for current limitation on the secondary, and that's the case for a net efficiency transformer. To explain to you the ideal of the transformer, here you can see a classical transformer, exactly like this one. This one is the case for a toroidal transformer. This one is classical transformer. The classical transformer has not the same current than a toroidal transformer, because the ideal of the transformer is sometimes about 200 milliamps, which is about 20 watts. Sometimes you can find more according to the size of the transformer and the power of the transformer. So when you connect a bulb on the primary of this transformer, if the bulb here are very low power, they can stay sometimes always on. This is the reason why in some case when you use a classical transformer and if you want to add some current limitation to protect your device you're working on, you need to put your low power bulb on the secondary and the big power bulb on the primary here, always switching by a switch here. If you connect this switch, you will have here this bulb. With this bulb will disappear, and you will have the 400 watts bulb and the 150 watts bulb available as power you can use from primary. And this is what I'm going to show you on my version 2 of isolated transformer box, which gives me the abilities to work on any device without phase and with limited current. Here you can see different bulbs. This is halogen lamp, and there is different power according to the size and the purpose you need. So here there is an erratum here, which there is a bulb you cannot use in this project. This is LED bulbs, because LED bulbs need a very low current, and you cannot use this kind of lights. You cannot use this bulb to make a current limiter, because it's the conception of this lamp cannot provide what we are looking for, because the incandescent lamp is able to provide a strong current from the start, but when more current is required, the the halogen lamp will glow up, and the resistance of this bulb will be more higher and regulate the current, and it's prevent about high current on your device. So for the instance, I show you this bulb, which is a 48 watts bulb, which is required sometimes for to make a very sensitive protection. If you are working on sometimes like phone charger or something like that, or maybe computer charger, you need a 50 watts bulb, which is able to prevent and which is able to feel, is more sensitive to prevent short circuit on your board and prevent about killing your board. So this is 48 watts bulb, and this one, which is actually on the drawer, you can see 3 lamp actually. You need sometimes like 3 lamp to make selectable power available on your box. And after the 48 watts, you will have here an halogen lamp, which is about 150 watts. Actually, it's 120, but the light coming from this bulb looks like it was 150 watts. You need, and it's hard to find now this kind of bulb because the LED are the king for the moment. But sometimes you need all the technology to make your purpose. This is 120 volts, which is the second lamp actually on the drawer, and this is 400 lamp, which is the lamp need to give the more highest power available on your circuit. But of course you can make some combination, and you can connect the bulb from the bottom together, or the bulb from the top together. Of if you want more energy, you can switch on all the power, all the switch together to have the biggest current you can need for some purpose. Also, this one is pretty rare, I think. This is a 1000 watt bulb. It can be used for a 600 isolated transformer, 600 watts isolated transformer. I think maybe I will need it further, but I don't know for the moment. Maybe it will be a nice project, maybe not, I don't know. So this is the kind of bulb you need, and absolutely not this one, which is an LED. Absolutely, this is not required for this kind of building actually. So now let's see the second version of my isolated transformer. Here you can see the version 2 of the isolated transformer box, and this configuration on the drawer is actually this one, because it has a toroidal transformer on it, and it can work with 3 bulbs just on entry to protect the winding, and it's work nice actually. This device is fully protected actually. It has this switch, and it gives you a voltage indicator here, which is actually the voltage output from the outlet here, and also those switch are according to the bulb you need. This is the 50 watts bulb, this is the 150 watts bulb, and this one is the 400 watt bulbs. And also there is, because this transformer was a simple transformer before a riding, especially for my purpose, so I keep the whole winding, and it's able to give me here 20 volts between those outlets and 40 volts here, and in addition of this voltage you can have 60 volts for your use for many purposes. So I'm going to show you the react of this display here with this China's LED display. You will see as consumption the consumption from the outlet here, and it's not exactly an ammeter. It's work like an ammeter, but actually it shows you a percentage of the maximal amps of coming from this device. So if I put this soldering iron, I don't know if you remember this soldering iron, but if I connect it here, you can see here the needle, which indicates to you there is the maximal voltage on the output, and this device is something able to provide some 20 or 30 watts instantaneous soldering iron. I made it myself. You can see it on a video on my channel actually. If I switch on, you can see there is light coming from the first bulb. This one, because it's selectable by this switch, and because I want the maximal protection on my output here. If I connect, you can see the power need for this soldering iron is too much for this calibration. What I need is to switch off this one and switch on this one on the middle, which is the 150 watts actually. So you can see here the needle is more stable because it indicates to you the voltage on output doesn't drop. And also you can see the consumption here, which here is about 1.6. Actually, you don't need to read the point, the dot here. It's told you you can it use 15% of maximal amps from this device to this soldering iron. Also, this soldering iron has two power. You can see the needle here, you can see the display. If I switch with the low power, you can see a different. Okay, this is because they use the same alternance, because this display used positive alternance, and this one is also used positive alternance in this mode. So okay, this is a strange mistake actually. So if you need more bigger, this LED, red LED, indicates to you that you have the maximal power, but you can also use all this switch together to have this the full power. So I'm going to show you here with a heater. You can see here, this is a heater for like a hair dryer actually, and you can use it for make some tube shrinker actually. So this is the maximal protection. If I switch on, you can see the bulb is completely lightening because it's too much for this little power. So what I need is, you can see the heater is starting, but not at full tilt, and you can see the needle. The needle is indicating to you that the output is about it's cut in half actually. And you can see here the display, which tells you are about 80% of the current. And here you can see you can see here the amps, which are more than enough, because this one is about 300 watts, and this device is made to give something like 200 watts maximal. So despite of it, it can give some energy to work with it, and if you need to make some troubleshooting or any device, you can use the power you need here. And to show you the abilities of this device, I'm going to show you okay, this is a nice tool, a little bit dirty but very efficient. I love this tool. I have it since a long time now, and I love to use it for tinkering. So this tool is absolutely amazing. If you want to switch on this tool, you can see a strange reaction because there is electronic on it, which is trying to make a regulated turning the motor with a regulated feedback. So if you put the middle power, which is 150 watts, you can see the reaction about the needle, which indicates to you there is a drop of voltage, and it's not able to fill completely. It's struggling. You can see the lights, and if I put more energy, despite the maximal current you can use on this box, it's able to give you enough power to work with this kind of stuff. If you need to work in a wet area, you can use this kind of stuff also. This one is very efficient actually, because I'm going to show you inside how it's made, and you will see toroidal transformer. And toroidal transformers are the best in this purpose, I think, because they have a very high efficiency, and you can put all the bulb on the primary actually. So this is the V2 version of my isolated box. I'm going to open this box, and we are going to see inside how it's made. So you can see here the toroidal transformer, and also you can see here the different bulbs with a thermal protection here. Here this is a whole model of lamp which is on her socket, and this is the 50 watts 48 watts bulbs, and you can see here the 400 and the 150 watts bulbs. So those switches are here to choose the bulb you want, and this is the here you can see the galvanometer, which was used to give the voltage output with an integrated digital display. This one is for the voltage, and this one is for the current actually. So here you can see the outlet for the low voltage section coming from this rewinding. I have rewinded this toroidal transformer myself, and here you can see this is a switching power supply coming from a phone charger, I think, and it's feed this little fan which make this bulb cooling actually when they heat up too much. And here, this is a very sophisticated board. I spent a lot of time to build this. This one is converting the current to a voltage for the digital display on it, to convert the current to a voltage. But because they are connected on the same main, it was very difficult, and sometimes the display was killed by an overvoltage. You can see here the little potentiometer to adjust the display according to the current which is going through this shunt. You can see here the bridge diode, which is required to make actually a DC voltage from the display. And there is also no, this is not the bridge for the display. This is for this bridge is used like a Zener diode to prevent overvoltage between the two poles of the shunt. This is not for rectifying. This is a bridge rectifier used like a Zener diode. The rectifying diode is something here, very little. I don't know if it's possible to see it. And it's a Schottky diode to prevent high voltage threshold, because you need to keep your voltage to have more efficiency, more accuracy about the voltage reading and converted it to amp reading. So as you can see, it's quite simple but very efficient. You will have the plug in the center of this toroidal transformer, and there is a switch, all are connected to this main switch here, which is the main switch actually. So this is all for this box. And as you can see, it's very simple, and this toroidal transformer is absolutely amazing because it's able to give high power with low consumption, and it works absolutely very nice. And also, this device is a short protect. If you have a short circuit on the outlet here, you can see the height power is protected by a thermal switch, which is here. This thermal switch is connected to the bulb. If the bulb becomes very hot, because it's always switch on, this switch is able to switch off and protect your device. I'm going to show you now with this example. Let's make it close and see you the protection. So I have a plug here, and I'm going to connect to this transformer, isolated transformer, and see how it reacts. So you can see the needle here is at the minimal place because all of those switches are off. This is the best protection with the 50 watts bulb. You can see here the needle, and I'll show you more closer. So, if I put a short circuit with the cable, look how it reacts. You can see light coming from inside the box, and you will have nothing. This is a current protection, and of course the needle shows you the drop of the voltage, and the digital display which shows you a percentage of current. So if I use the middle power, you can see I have more current. You can see sparks coming from this box. There is a dangerous voltage, but if I want to put a finger on it, it doesn't hurt me. If I put my finger on it, but you have not to touch the two wires at the same time, because there is always different dangerous voltage. But I can touch this one, or I can touch this one. I feel absolutely nothing, because the output are not grounded like the main voltage. This is the main purpose of this transformer. But this one has a special features because it has an integrated bulbs to prevent overcurrent. Let's see this one. You can see the sparks. It gives a big sparks. And if I connect this one, which is the 400 output power, you can see there is a big sparks here. And what happened if I put a short circuit? Actually, there is a big short circuit. It switch off, automatically switch off. You can see some smoke coming from inside because there is some dust on the bulbs, and also there is a fan who makes cooled and chill the area with a cooling air. So you can see there is no more voltage, and if you wait a little bit, because there is a fan for cooling all this stuff, this is a thermal protection actually. Of course, in a normal use of this box, you don't have to put a frank short circuit like this. This is just for testing this device actually. If you wait a little bit, you can see the needle here is always on 0, and if you wait a little bit, you can see it will gives the voltage. For the moment there is absolutely nothing. I look at the needle. We need to be patient a little bit. Okay, you can see the needle is going to the maximum now, and you will now have the voltage on output. The sparks you can see is the sparks according to the power you selected on the billboard here. You can switch off like this, but this panel is still switching on. If you want to switch off, you need to switch off by this button. This is the version 1 of this galvanic protection, isolated transformer galvanic protection. Now you have seen some information about this version 1, version 2 of my isolated transformer box with an isolated transformer inside, which is amazing actually, because it's serial transformer. It's a nice, very nice tool. You need to have this stuff to make some troubleshooting. So I had a colleague, and sometimes when he tried to make some troubleshooting, it's always connected his device to the main, and I managed to convince him to give to have an adapted box like this one, and he asked me about a schematic, but so I tried to help him, and to give to him the opportunities to work safety. And this is a reason after this V2 I made a V3 models, which is here actually. This is V3 version, through the third version of insulated transformer, which is able to give you safety for working on the main. So this one is not so different comparing to the other. So it has an outlet, and also it have a meter like this one, which is actually not for this, absolutely for this purpose, because this one is rated by, it's rated for 100 microamp, which is not here for our concern, because we are interested about the position of the needle inside on this display. It has also a digital display to gives you a percentage of the maximal amp you are providing on the output here. and it have some button. The button here are here the main button to switch on the device, and this one is able to transform this box on simply an isolated transformer without the thermal protection, without the current limiting. If you want to connect something, a power tool here, you can use this device and working in wet area. And for this purpose, you can see here a green light. If you touch the button, the green light will disappear, and you have directly from the transformer the outlet connected to the transformer without any current limitation. Also, for this purpose, you need to switch off the final protection. The final protection is what I mean. What I want to tell is on the schematic here is about this drawer here. This device is built around a classical transformer, which is not actually, sorry for this, a toroidal transformer. It has a very idle, which is about 30 watts, I think. And if you if you put this little bulb with the lower power on the entry here, it's always stay on. So you need to put this bulb on the secondary, and for the high power bulb, you need to connect it on the primary. Of course, if you want, you can connect all this bulb on the primary, but of course, if you want to prevent any frank short circuits about what can happen on your box for many reasons, if the winding is burned or if it's melt. This is what happened to me actually in my last box. You will have a short circuit, and if you don't have a fuse, you can put your current limitation on the primary to prevent a short circuit. This is my favorite way to use this kind of current prevention, current limitation. So the second version is this schematic, but this version here is this schematic because the idle of the transformer is absolutely not the same than this one. This one is about 7 milliamp. This one is 300 milliamp. The idle is very high comparing to this one, because this is a classical transformer. This is not a toroidal transformer, and you know that the toroidal transformer have higher efficiency, and sometimes it's better to use this kind of stuff. So to get back to our ship, you can see here some button, etc. I make some explanation about that. And of course, to make this device very heavy and duty, I put a fan on it. And that means if you want to use this device 24 o'clock without any hesitation, you can use it, because there is a flow on it to prevent any overheating. You know about some components, they can become very hot, and when they comes hot and hot again, and this is what we can in French emballement thermique. In French, in English you can call it the thermal runaway, I think. And to prevent the thermal runaway, you can use this fan here, which is connected. It's turned very slowly, but it's enough to give little chill and more cooling on it to prevent about heating. So you can see here through this glass a big transformer about 200 watts and some electronic for driving all this stuff. I'm going to remove this cover and show you what there is inside. Here you can see the transformer, which is 200 380 volts, which is exactly the same that this one, but more bigger. You can see here E1, E2, S1, S2, which is exactly the same that this one, but this one has a power of 250 watts, whereas this one is about just 100 watts. So you have here this switch which is an industrial switch. Other switch or industrial switch with, and that means it's a very nice switch for intensive use. This one is China's voltmeter, and this voltmeter is arced to give some amps. But this amp is converted with this shunt here by percentage. So if this device is able to give 2 amp, the number displayed on this voltmeter is about 1% of maximal amps you can have on this device. So here, as this, it's the same than the previous version. You can see different bulb here. This one is the 400 bulb, and this one are connected together to give an average wattage is about 250 watts. And this one is the 480 watts bulb to protect sensitive boards when you are troubleshooting. This one is a thermal protection, but in the two version here, in this version, the protection is about 75 degrees, but this one is about 100 degrees. And if this one is switching, you need to push here to make to make it available to switch on, because it needs a push when it's switched off. When it's switched off, you need to restart it. You need to push this button. So it's a pain in the neck if you have an overheating, but normally you don't have, because this is just in security mode. If it's not supposed to happen sometimes actually. So this is the version 3 of this galvanic box. You can see here a fuse, because this device is made not for my purpose but for my colleague, and so safety is the first goal here. So this box comes from a Moisture Control and Measurement Ltd, which is an analyzer department in a factory. And so to tell something about this, if you are interested to understand how it's proceed, this button is able to short circuit the limitation about 484 48 volts, 48 watts, sorry, and this green LED is showing you that it's there is the maximal protection. This one is the button for the middle protection, and this one for the height protection. This one is for the 400 watts protection. This one, the 230 watts protection. You can use together, of course, but if you want to use this device directly from the main to the outlet without any current limitation, you have just to push this button. This button is able to short circuit all the protection. Of course, you need to disable this protection also, and you will have here a protected, an isolated output, and you don't have to worry about the voltage or limitation if you want to connect a power tool to use it, on a wet condition to prevent any electrocution or any stuff like this. I'm going to show you how it works with big tools connected on this device. So here I'm going to test this one on it, this soldering iron, instantaneous soldering iron, and you can see here this is the main bulbs connected to the main here, the 400 and the 230 watts. So I switch on, you can see here a green LED, green light, which indicates to you the device is on protected bulbs. So this one shows you that the output protection, the bulb, the output bulb is short circuit. So this device is connected on the high power protection. And you can see here a consumption of this device, and of course a little bit of drop because this is high power bulbs. If I switch off the short circuit, so you have here the maximal protection, the current is going through the bulb, the 50 watts bulb, before to go to the outlet. You can see here a significant drop of the voltage, which indicates to you this device is consuming a lot of current, and you can see it's drop the voltage, and it gives you an idea about the maximal percentage of the current available of this unit. So if I want to use this unit like just an isolated transformer, I have to push this button. When I push this button, I need to switch off this green LED also, and it becomes red. In this case, all of the power coming from the primary go in the secondary, and I have it in this soldering iron. So now it's working at full tilt. You can see here the consumption, which is nearly about maybe 20% of the maximal amps you can have on this unit. And now you can solder with this device. You can see there is absolutely no dropping voltage because it's connected directly to the secondary. If I want to use some protection here, you need to have the green LED. In this case, you will have this one and this one. This one is the 400, this one is the 150. You can see there is nothing because it's enough to protect this device. 250 watts is enough to provide this stuff without glowing, I mean. So if we want to make a more power tool on it, you can use this powerful, you can see this protection is connected. Also, I can use in the same time, but for this moment, I'm going to use just the 400 protection, and you can see the light coming. You can see the light coming from the bulb, which is it's considering that it's limiting the current against other current actually. So if I want to use this device directly with the transformer, I just have to push here the button, and here it's directly connected to the output of this device. But this one is 300 watts, and the transformer is about okay, something is broken. So okay, I need to put some glue here because this switch sometimes open itself because its salvaged part is not perfect. I need to put a glue here to maintain on this position. This is to prevent this switch from moving backwards. This is actually what happens. So in this situation, if you want to use a tool perfectly isolated from the main, you can use this button here. So you will have a perfectly isolated connection from the main. And if you go back, the current goes through the bulbs for the protection. And this is the 240 watts protection, which is here. In addition, 600 watts. Of course, this one is the maximal protection, which is to be disabled actually. So if we want to connect a more power tool, as this sea sorter, I don't know how to call it in English, sorry. This is I don't know how to call it in English. So if I want to use it with a protection, as you can see, there is a protection going through this switch and the bulbs. You can see the needle here showing to you the voltage output. And I'm going to connect directly to the main, to the output transformer. If I disconnect, the light switch on. You can see actually the consumption of this stick gun. You can see the voltage is dropping, and it's going more higher because there is a PTC inside. And you can see the consumption is decreasing according to the component there is inside. So if you connect this one, which is not the same technology as the other, you can see a drop in voltage and the maximal consumption, because it's waiting for to be more heat, to be more hot. Actually, it needs to be more heat to could disconnect a switch on it. This is the reason why you can see a dropping voltage here and maximal consumption. If you wait a little bit, after a while, okay, did you see it? The narrow is going to its first place, and the consumption is about 0 now. And because this one has a switching system on it with a B-lamp actually. This is a heat sensor, and it moves from bottom to top to make a electrical connection to provide the power to the heating element, and when it becomes hot, it switch on to regulate the power. Actually, when this device will becomes more cold, and you can see it will return to the first place, and you can see the narrow returning from the back actually. This is how you can analyze some stuff with this kind of needles and this current consumption, and it returns to its first place. So, of course, the main purpose of such kind of device are to protect your scope from the ground coming from the device you're working on, because if you use this kind of probe with this kind of scope on a regular circuit connected to the main, like a switching power supply actually, you can use accidentally, without purpose, your ground on hot points, and you can make several damage to your scope, to your circuit, or also to yourself. So to prevent any danger coming from this kind of situation, you absolutely need to use isolated transformer, not mandatory with a heating element preventing about overcurrent, but just isolating your circuit from the main. The purpose is to erase the ground abilities of your circuit, because the chassis is connected, the chassis of this scope, this regular scope, is connected to the ground of your connector in the back. The other solution is to use battery mode fluke like this one, scope working with a battery inside. There is onboard batteries which provide to you to work without connecting anything to the main, and it can make the job, but I prefer to use this kind of scope for troubleshooting because it's more accurate, more quick, more readable actually, I found. So of course, if you need to work safety with this kind of scope, you absolutely need an isolated transformer. You can use a simply regular transformer like this and use the primary and the secondary, which permits to you to work safety. So the first purpose of such a device is to work safety, absolutely safety, with this kind of probe on this kind of regular scope. I hope you like this video. It was Alexander again, and see you soon.